Hi, welcome to my video on rational functions. And this video is going to be on the rational where the denominator is a product of two binomials. So f of x equals d over x minus a times x minus b plus k, where a, b, d, and k belong to the real numbers, and most of these values will be in terms of integers. Okay, let's graph the f of x equals 1 over x plus 2, x minus 2. So this equation becomes y equals 1 over x plus 2, x minus 2. And I write the f of x in terms of y to make it a little bit easier, since I could have f of x here, but it's easier to put a y. Now, the vertical asymptotes is when your denominator equals 0, so that means that x plus 2 equals 0, or x minus 2 equals 0. So x equals negative 2, x equals 2. So the vertical asymptotes are at x equals negative 2. So that's this one. That means the graph will not cut through this vertical asymptote, x equals negative 2. Or it will not cut through x equals 2, the vertical asymptote, x equals 2. Now, what about the horizontal asymptotes? The horizontal asymptotes, if you look at this equation, as x goes to infinity, your denominator is infinity times infinity, so 1 over this number, infinity squared, is going to 0. So your asymptote horizontal is y equals 0. So let me put a dotted line through here. So that means this is y equals 0. So that means that as x goes to infinity, y will approach 0. So it either goes this way or this way. As x goes to negative infinity, the y value goes to 0 is either here or it's here. So let's decide that further. Now, let's look at the y-intercepts. And that y-intercepts is when we let x equals 0 in this equation. So y equals 1 over 0 plus 2, 0 minus 2. So that means we have 1 over, it has 2 minus 2, so that's negative 4, so it's a negative 1/4. So when x is 0, y is negative 1/4. So that's the y-intercept, 0 and negative 1/4. So let's put that dot right there. That means the graph will pass through this y-intercept. Now let's look at the x-intercepts. So the x-intercepts are when you let y equals 0. So take this equation, put 0 in the place of y, and we get 1 over x plus 2 times x minus 2. Put 0 over 1, cross multiply, 0 times this two binomials is 0, and 1 times 1 is 1, and 0 equals 1. That means there's no x-intercepts, because 0 can't equal 1. So it's not going to pass through the x-axis at all. So to look at that, let's look at some values. Let's look at, we have right here at negative 2. So let's look at a few values to the left of that. Let's look at negative 4, negative 3. We know what negative 2 is. Negative 1, 0, 1, 2, 3. Let's look at some of these values along this x-axis. So if we take this equation and put a negative 4 in here, we get 1 over negative 4 plus 2 and negative 4 minus 2. So that becomes 1 over that that's negative 2 times negative 6, so that's 1/12. And we'll plot all these after. Let's put a negative 3 in, and negative 3 plus 2, negative 3 minus 2, so that gives us 1 over, and that's negative 1 times negative 5, so that's a 1/5. Negative 2, we know it's undefined because it's an asymptote. Okay, and let's put a negative 1 in, so it's 1 over. We're putting a negative 1 in the place of x right here, so it's a negative 1 plus 2, negative 1 minus 2, and that gives us 1 over. That's a 1. That's negative 3, so that gives us a negative 1/3. Now we'll put 0 in. We already know what 0 is because we worked it out, so that's a 1/4. Let's put a 1 in, and 1 over 1 plus 2, 1 minus 2, so that's 1 over 3 times negative 1, so that's a negative 1/3. And we'll put a 2 in, and a 2, we know what 2 is. 2 is undefined because it's a vertical asymptote. And let's put 3 in, 1 over 3 plus 2, 3 minus 2, 1 over, that's a 5 times, and that's a 1, so that's a 1/5. And one more, let's put a 4 in, 4 plus 2, 4 minus 2, so that's 1 over 6, 4 plus 2 is 6, times 4 minus 2 is 2, so that's 1/12. So let's plot these now. Negative 4 is 1/12. Negative 4 here is close to the x-axis. Negative 3 is 1/5, is a little bit higher. Let's say we're just approximating these. Undefined. Negative 1 is negative 1/3, so negative 1 is here at a negative 1/3. So this is a negative 1/4, so negative 1/3 is a little bit more, so we'll go a little bit lower than this one. Undefined at or 0 is negative 4, 1 is negative 1/3, so 0 is negative 1/4, and 1 is negative 1/3, same as this one, and 2 is 1/5, so sorry, 3 is 1/5, so 3 is 1/5, which is again the same as what the negative 3 is, and the 4 is 1/12, same as what the negative 4 here is. So as x goes to infinity this way, y goes to 0, so it has to be coming down like this because this is higher than this one. So, and as you approach the asymptote, it goes to infinity. And on the other side is the same, only here it is here. Again, as x goes to negative infinity, y is going to 0. And as you approach this asymptote, it's going to infinity. And in here, it looks like this is the highest point, so it looks like it's doing this and this. Just a rough sketch. So on this side, on the left side, it's going to infinity. On the right side right here, it's going to negative infinity. And here, as it approaches 2, it's going to negative infinity. As it approaches, this is 2 on the left. As it approaches 2 on the right, it's going to positive infinity. So again, we have 2 vertical asymptotes, and we have the graph is on the outside of each of these, and So there's a graph in the middle. In this case, looks like a part of a parabola in the middle. Okay, let's look at this one. F of x equals 1 over x plus 3, x plus 1, add on 2. So this equation, we make this equation y equals 1 over x plus 3, x plus 1, add on 2. And we'll look at the vertical asymptotes of this one. So it's when you let your denominator equal 0. We have 2 of them. We have 2 vertical asymptotes. One is at -3. Oh, make that a -3. And the other one is at -1. So it's a vertical asymptote at -3, which is right here. So this is x equals -3. And the other vertical asymptote is at x equals -1. And let's have a look at the horizontal asymptotes. The horizontal asymptotes, notice we got 1 over, so the denominator gets larger and larger and larger. So this 1 over, this fraction is getting smaller and smaller and smaller, approaching 0. So that means the y value is approaching 2. So the horizontal asymptote is y equals 2. So that's right here. This is 1, 2, 3. So this is the 2. Make that y equals 2. So that's the horizontal asymptote and the 2 vertical asymptotes. Now, let's look at the y-intercept. So the y-intercept is when you let x equal 0. Take this equation and put a 0 in. So we get y equals 1 over 0 plus 3, 0 plus 1, add on 2. That's a 3 and that's a 1. So that's when you multiply 3, so it's 1/3 plus 2, so it's 2 1/3. So that means when x is 0, y is 2 1/3. When x is 0, y is 2 1/3. Let's take that y-intercept to be right there. So it looks like the graph is coming like this, because as x goes to infinity, y is approaching 2, so it looks like it's coming here. So I would say this graph is here and here. And how does the middle fit in? Well, let's look at the x-intercept. The x-intercept is when you let y equals 0. And when you let y equals 0, and the equation, so we're going to put 0 in the place of y here. So 0 equals 1 over x plus 3, x plus 1, add on 2. The LCD is this denominator here. So when I multiply 0 by this 2 binomials, we get a 0. When you multiply 1 over these 2 by itself, we get 1. And we get x plus 3, x plus 1 times. So I multiplied through by the LCD. Again, I got a 0, a 1, and 2 times these 2 binomials. There it is. And we simplify that. We get 0 equals 1 plus, let's multiply first, FOIL. First, outside, inside. Outside is x, inside is 3x, so that's a 4x. And last is 3. So we have to keep multiplying. 1 plus 2x squared plus 8x plus 6. And we simplify that as 2x squared plus 8x plus 7. So this is a quadratic, and we can factor this, but the factors of 7 to give me factors of 2, 8. Can we combine? How do we get 8? Well, that's a 2 and a 1, a 7 and a 1. So it looks like it's not going to give me an 8, so I have to do the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. b is 8, so that's negative 8, plus or minus, that's an 8, so that's an 8 being squared minus 4, a is 2, c is 7, all over 2 times a, which is a is 2. So we get negative 8 plus or minus, and that's a 64, just make it short, and that's a 56, so that gives me an 8 over 4. So there's negative 8 plus or minus, and the square root of 8 is 2.8 over 4. So that's negative 8 plus 2.8 over 4, or negative 8 minus 2.8 over 4. And that works down to be negative 1.3, and this is a negative 2.7. I just worked the calculators and you get that. So that means this point here is x is negative 2.3, y is 0. And right here x is 2.7 and y is 0. So negative 2.3, x is 1.3 and y is 0. So that's, let's say, that's negative 1. So 1.30 is it right here. Just take a guess. And this one is negative 2.70, so that's negative 2. So we say negative 2.7 is 0. So the graph is going to cut through the two of these points. Okay. And what about the 2 in the middle? So we don't know if it's going to go this way or this way. So let's check. Let's check with a table. And let's put, we know what, if we put a negative, let's put a negative, just to see where the graph is. Let's go on this side first. We put a negative 4 in. We get 1 over negative 4 plus 3 and negative 4 plus 1. And we're going to add on 2. So that gives us, let's see, negative 1 times negative 3 plus 2. So that looks like it's going to be 1/3, so it's a 2 and 1/3. So negative 4 is 2 and 1/3 right there, and that's the same as this one. So we know the graph, so that means it's probably going to go up here and like this. This makes sense. As it goes towards this asymptote on this side, it goes to infinity. As it goes towards this asymptote of negative 1 on the right side here goes to infinity. This goes to infinity. And as it goes, as x goes to negative infinity, y is going to 2. As x is going to positive infinity, y is going to 2. And let's check the negative 2. Let's check in the middle here, see what we get. So that's 1 over negative 2 plus 3, negative 2 plus 1, add on 2. And what does that give us? Let's see. That gives us 1 over, that's a 1, that's a negative 1. So that's negative 1 on the bottom. 1 divided by negative 1 is negative 1 plus 2. So that's a 1. So this point is 2, negative 2, 1. So that's the point, negative 2, 1. Negative 2, 1 is right here. So the graph is coming down through here, like this, and coming down here. So as we said, it's on the outside and there's a parabola in the middle. But we found the 2x intercepts by using the quadratic formula, and we found this point. So there's its shape. Okay, let's have a look at one more. And this one, again, we have a denominator of a negative. So this equation becomes y equals negative 1 over x minus 1, x minus 5. And we could put plus 0. So the vertical asymptote is x minus 1 is 0, or x minus 5 equals 0. So the vertical asymptote, x equals 1 and x equals 5. X equals 1 is one vertical asymptote. X equals 5 is another vertical asymptote. And the horizontal asymptote, as x goes to infinity, this fraction goes to 0. So we look at right here, or this one, to make it different. That means the horizontal asymptote is y equals 0. There it is, y equals 0. So it's going to go along by this asymptote. As it goes to infinity, then it will go to 0. Again, is it here or is it here? And here, is it up here or is it down here? We'll check. Let's see. So let's find the y-intercepts. So the y-intercepts is when you let x equal 0. So let's take the equation and put y equals negative 1 over 0 minus 1, 0 minus 5. And that gives us negative 1 over. That's negative 1, negative 5 is a 5. So that means that point x is 0, we get a negative 1/5. When x is 0, y is a negative 1/5. And that's roughly right there. That's the y-intercept. Let's see what the x-intercepts are. X-intercept is when you let y equals 0. So 0 equals negative 1 over x minus 1, x minus 5. Put it over 1. Cross multiply 0 times this polynomial will give you 0. 1 times negative 1 will give you negative 1. So 0 cannot equal negative 1. So there's no x-intercepts. This graph will not cut through the x-axis. And as a result, let's have a look at a table of values to see. So again, it'll tell either it's here and here, or it's here, here. So let's put in 0. So we know what 0 is. At 0 we have this one. So 0 is a negative 1/5. We know a vertical asymptote here. Let's put in a 2. And let's put a 2 into this equation. So we get a negative 1 over 2 minus 1 and 2 minus 5. So negative 1 over, that's a 1. And that's negative 3. So that's negative 1 over negative 3. So that's a 1/3. We'll plot these after. Let's put in a 3. So it's a negative 1 over 3 minus 1, 3 minus 5, negative 1. That's a 2. And that's a negative 2. So negative 1 over negative 4 is a 1/4. And let's try a 4 and see what we get. Negative 1 over, that's 4 minus 1, 4 minus 5, negative 1 over, that's a 3, that's a negative 1, so negative 1 over negative 3 is a 1/3. And we know what the We know the 5 is going to give us a vertical asymptote, so let's put 6 in. So negative 1 over 6 minus 1, 6 minus 5, negative 1. That's a 5. That's a 1. So that's negative 1/5. So let's plot all these. So x is a negative 1/5. So that's right here, the same as this one. 4 is 1/3. 4 is 1/3. So let's say we got a 1/3, 1/4, 1/3. So 1/3 is a little bit higher. 1/4 for 3 is a little bit lower because 1/4 is 0.25. 1/3 is 0.33. And 2 is 1/3, is a little bit higher. So we can see it's here, hitting here. So that means the graph must be doing this and this, and it's in between here. There it is. So the outside is below because it's negative, it's turned over. If this was positive, it would have been up here. And this one would have been going down here. But it's flipped over because of the negative. So it's reversed. It's reflected with the negative, it's reflected in the x-axis. So if you look at the other one, I just go back and show you one of the other ones. Notice when it's positive, it's here and like this. But when it's negative, it's flipped over, so it's reversed. So this down here is up here. Excuse me. And that brings us to the end of this video. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.